That flash is lightning inside the eye of Hurricane Lee. The people filming it flew there on purpose. This is real U.S. Air Force hurricane hunter footage, not a simulation. And the reason they enter one of the most violent places in the atmosphere is simple. A satellite can see a hurricane, but this aircraft can feel what is happening inside it. From space, forecasters can track cloud patterns and estimate a storm's movement and strength. But the most important details can be hidden beneath those clouds. What is the pressure at the center? Where are the strongest surface winds? Is the storm reorganizing, weakening, or beginning to intensify faster than expected?
To answer those questions, the Air Force Reserve's 53rd Weather Reconnaissance Squadron flies a specially equipped WC-130J directly into tropical storms and hurricanes. A typical crew has 5 people: a pilot, co-pilot, navigator, aerial reconnaissance weather officer, and weather reconnaissance loadmaster. The aircraft is not trying to outrun the storm. It follows a planned pattern through it. During a fixed mission, crews may penetrate the eye 2 to 4 times, usually at altitudes up to about 10,000 feet. The roughest transition is the eyewall, the ring of intense thunderstorms surrounding the calm center. Outside the window, visibility can disappear. Turbulence, heavy rain, icing, and lightning can all arrive together. Then the aircraft breaks through, and the view can change almost instantly. Inside the eye, blue sky or stars may appear above a circular wall of cloud. But the spectacular view is not the mission. As the plane crosses the storm, its instruments report temperature, pressure, humidity, wind, and rainfall. A step frequency microwave radiometer looks down at the ocean and estimates surface wind speed and rain rate. The crew can send weather observations as often as every minute through a satellite link to the National Hurricane Center. Then comes the small instrument that makes the vertical picture possible: a dropsonde. A crew member releases the tube through the bottom of the aircraft. A parachute stabilizes it as it falls toward the ocean. On the way down, it measures pressure, temperature, humidity, and wind speed and direction, transmitting those readings back to the plane. One dropsonde through the eyewall can reveal how the wind changes from flight level almost all the way to the surface. Another released in the eye helps locate the center and its lowest pressure. Those measurements are added to forecast models and examined by forecasters in real time. NOAA research has found that aircraft reconnaissance data can materially improve both track and intensity forecasts, especially during the critical days before possible landfall. That improvement changes real decisions. Emergency managers decide when to open shelters. Airlines reroute flights. Ports close. Families decide whether they still have time to leave. A small change in the predicted track can move the greatest danger from one community to another. So hurricane hunters are not entering the storm for dramatic footage. They are turning a huge, partially hidden system into direct measurements. One eye crossing, one radar scan, and one falling sensor at a time. The lightning is the part we can see. The forecast is the reason they fly into it. Subscribe to Wide Spike for more real footage, hidden clues, and fast answers.